Okay, so today I want us to solve or see how we can find the inverse of Laplace. So Laplace inverse of. So we are using this example, and this need a very it's a very critical question. We need to digest it before we can solve it. Okay, so you should find the Laplace inverse of this function s plus 4 over s squared plus 4s plus 8. When you find the factors of s squared plus 4s plus 8, you realize you are going to get um, a complex root. Okay, so we do it alternatively. Okay, so just take the denominator, this. The denominator can be written as uh, it can be written as s squared plus 4s. This is the 4s plus the 8, but the 8 can be written as 4 plus 4. Okay, so I know that I can split this. So here s squared plus 4s plus 4. This now becomes very simple with a simple quadratic root, and this one can be written as s plus 2 all square plus the 4. Okay, then it makes our solution very simple. So you are going to get s plus 4, and now the denominator will now turn to s plus 2 all square plus 4. Okay, so we are coming to find the Laplace inverse of this. So here is the trick. So we just separate it. S plus 4 all over s plus 2 all square plus 4 can be written as s over the s plus 2 all square plus 4 plus 4 over s plus 2 all square plus 4. It's the same thing. Okay, I've done nothing to the question. So this is the same thing. Yeah, I just separated it. Okay, so this is what I intend to do. We know that s is here, and with this and the denominator, we don't have any Laplace table that relates to it. Okay, it becomes very difficult for us to do that. So we just, because there's 2 here, someone may just ask, why did I added the 2 and at the same time subtracted the 2? So you know that I have done nothing to the question. The question was s, or we had s over s plus 2 all square plus 4. So the s here can be written as s plus 2 minus 2. So in actual sense, the 2 cancels the 2 and you get back to this. So the same thing. This, I've done nothing to it, plus this is here. And also s plus 2 minus this, I can still separate it. So we are going to get s plus 2 all over s plus 2 all square plus 4 minus 2 over, so it's the same thing, s plus 2 all square plus 4, then plus my 4 over. So this become very easy for us to use the Laplace table to find our solution to the question. Okay, so find the Laplace inverse of this, Laplace inverse of this, Laplace inverse of this. So we just see that whenever we have a Laplace inverse of s minus a all over s minus a, this is due to shifting. We have already learned from our previous videos how we had this and how we will use it to solve. We've already learned about it. Okay, so whenever we have Laplace inverse of s minus a all over s minus a all square plus beta square, you are going to get e exponent at cos beta t. Here, this is your beta, this is the beta t. Okay, also whenever you have a Laplace inverse of a over s minus a all square plus b square, this is equal to e exponent at sine beta t. It's nothing, it's just the shifting. The s minus a is due to the e exponent a. In the actual sense, it's supposed to be s over s. It's supposed to be s over s square plus beta square. But because of, it's supposed to be this. But because of e exponent at multiplying the cos beta t. Now, wherever you see your s, just make this substitution s minus a. So, and wherever you see here, this one you are going to get s minus a all square. Okay, that's why we had this. Okay, so very simple. The same thing apply to this. Okay, so we are using this to solve it. So from the equation 1, we've already known that whenever we have something like this, we are going to get this. So if this becomes positive, it means my e here will become negative. Yeah. So see, whenever we have, so here the s plus 2 over s plus 2 all square plus 4, we are going to get e exponent minus alpha or the at. The a is 2, but here was negative. Okay, so it will make the a, that's the 2, to be e exponent negative 2t. Okay, cos 2t, and the beta 2 is beta square. You know that beta square will give us the 4, so it means my beta is 2. So it means my beta is 2. Okay, so also the 2 over s plus 2 all square plus 4 2. You know that is the same thing as it will give us e exponent minus 2t sine 2t. So Laplace of inverse of this is, so the 2 here is the beta, and the minus 2 here is the a. So the a and the beta. Remember when it was minus, we had positive a t. So whenever it becomes positive here, the a becomes negative. Very simple. Okay. So the same thing. My a becomes negative. Okay. Here too is 4 over s plus 2 all square plus 4. And you know that this can be written as 2 times 2 over s plus 2 all square plus 4. Okay. And you know that we know the answer for this. The same thing. We had e by minus 2t. So we just multiply it by what? 2. Okay. So just multiply it by 2. So you are going to get 2. Okay, sorry. So 2 multiplying the e exponent minus 2t sine 2t. So you just combine this, because we saw that this gave us, we said we should find this. Okay, and now we've worked up onto this, so we just add the result. This, the s over this, that's the s plus 2 minus 2 over, so we just add them. So just add them. Okay, so when you add them, you are going to get e exponent minus 2t cos 2t minus e exponent minus 2t sine 2t plus 2e exponent minus 2t sine 2t. Okay, so see, e exponent minus 2t sine 2t. Okay, so you know that the minus is here and positive 2 is here, and they are the same, so you can add them. So you're going to get e exponent minus 2t sine 2t. Okay, so that's all. Okay, so thank you very much.